right? We're talking about angles of elevation and depression. I know your picture in the print notes looks different from the one that's up here on the screen, but it still covers the same type of concept, okay? Angle of elevation always comes from your eye level. Some horizontal line either looking up or looking down, okay? So you lift your eyes to look at something, that's your angle of elevation, and you lower your eyes to look at something, that's your angle of depression. But no matter what, both of these are coming from horizontal lines, okay? Originally, the dog was looking straight forward at the base of the tree, but when he noticed the bird chirping, he looked up, and that angle formed the angle of elevation. And the bird, she was minding her business, looking out into the world, and then noticed a barking dog, and so she looked down, and that was her angle of depression. That was really loud. All right? In your printed notes, it has basically an eye. So just remember, it comes from some horizontal line of sight, and then going up or going down. Now, both of these horizontal lines are parallel because they're horizontal. Horizontal lines are parallel, yes. Okay? And this angle here that's created creates these two types of angles. Anybody remember from geometry what those angles were called? This angle of depression, this angle of elevation? Interior something.
Oh,
It was a say again? Alternate interior angles. And alternate interior angles are formed when you have two parallel lines cut by transversal. And alternate interior angles are what? Say again? Congruent. So yes, your angle of elevation, your angle of depression, depending on the problem, guys, is that they're going to be equal to each other. This is going to be helpful, especially when you're dealing with your word problems when it comes to angles of elevation and depression. Okay? So, first example we're going to look at is one that's actually one that you're going to add to your handwritten notes. We're going to do this one together, and then you guys are going to do the two printed note examples on your own, and then we'll go over them. Okay? So, here's the first example. I'll give you a minute or two to write it down, and then we'll start going over it. So, from an observer O, 200 meters from a building, the angles of elevation to the bottom and to the top of the flagpole are 36 and 38, respectively. Everybody knows what respectively means, correct? Yes. No, not approximately. It just means like basically it listed two things, and then those angles go with those two things, like in that order. Mm-hmm. So it says the angle of elevation to the bottom of the flagpole goes with the first angle, so 36. Okay. And then to the top of the flagpole go 38. All right, that's what it means respectively. Then it says find the height of the flagpole. So guys, if this is the bottom of the flagpole and this is the top of the flagpole, they want you basically to find this length right here. Okay? But looking at this picture, what do you see? What type of triangle? Not a right triangle? There's two triangles? What type of triangles are they?
Not a right triangle.
We have one triangle.
You have two right triangles. You do have two right triangles. And yes, when they talk about a building, that building is perpendicular with the ground. Okay? We're not talking about the Leaning Tower and up in Paris or anything like that. It is straight 90 degrees. Okay? So we have two right triangles, okay? The first, or not the first one, but one of them has an angled measurement of what? Okay. Of 36. The base is still 200. And then there's another triangle that has an angle of what? 38. Okay? Now the triangle that has the 36-degree angle, okay, it will basically go to the bottom of the flagpole. Does everybody see that? Okay. And then the one with the 38-degree angle goes to the top of the flagpole. How can we find, like, let's kind of come up with a plan of how to go about finding the height of the flagpole. Okay.
One thing we can do is we can find the last angle, and then we can find the height of all the sides of the triangles.
The heights. Okay. So we can definitely do that. We can find the angle. Why would finding the angle be helpful?
So that we can decide whether to use sine or cosine.
True. We can definitely figure out the remaining angle. That way we're able to use, sine and cosine, kind of freely with whatever angle we want to use. And then we also need to find the heights. Okay? Finding the heights will allow us to basically determine this length as well as this length right here.
And then all we have to do is minus that length from that length.
Exactly. All we have to do is minus the orange length from the blue length. Okay? So let's find the blue length. The blue length is on this triangle. Let's call it x. What trig ratio are we going to use to find x? Tangent. And I would say using 36 versus 54 would be better, because what's going to be on the top of my ratio? It's going to be the 200, it's going to be the x.
It's going to be the x.
The x. What's going to go beside tangent? Skip the steps. 180 minus 36. So we'll have x over 200. Now to solve for x, we're going to multiply, we're going to divide 200 and tangent 36. Multiply. And we get a value of 360. That's around 360. Give me a few decimals after that. Okay? Because the thing is that we got to use these values to find the actual answer. And so we don't want to round the height of the building and then round the total length of the flagpole in the building and then subtract it and then round again. That's like a lot of rounding, getting further and further away from the more exact answer. So if we use these long decimals, it will get close to the more correct answer. Now let's find this orange length. This orange length, let's label it y. What trig ratio are we going to use? Tangent 38 equals what over what? Y over 200. Multiply or divide the 2. And so the complete, flagpole, top of flagpole down to the ground is how long? So then to find the flagpole, what we're actually looking for here, we get that value by subtracting the 2. So go ahead and subtract those values. Remember, you're subtracting the larger one from the smaller one. So this answer we can round, because that's our final answer. So what is it? 366? 10.9 meters. Confirmation?
Yes.
There it is. Okay. You can also use like the exact points before you actually type into your calculator to get that. It works as well. Questions? Did you see how the angle of elevation came from the horizontal line, which represented the ground, and then the line of sight going to the bottom and the top of the flagpoles? Okay. So now go to your printed notes, and I want you guys to do examples 6 and 7 on the back, and then we'll go over them in about 7 minutes. It says that a boy standing on a hill at X sees a boat at a lake at Y. So the boy is standing here. There's a boat at the lake. The vertical distance between X and Y is 60. So this distance right here is 60. And the horizontal distance is 100. Now, not by my picture, but the picture in your notes showed that distance was 100, right? Part A asks you, what's the shortest distance between the boy and the boat? Which is, what is that? The hypotenuse. How do you find the hypotenuse? A squared plus B squared equals C squared. Okay, so this is part A. That is going to be what number after you square it and add them together? Then you have the square root, and that is
About
117 meters. Okay, remember the shortest distance between 2 points is a straight line. Now part B says the angle of depression of the boat from the buoy. That's what you have to find. Now realize angle of depression, just like angle of elevation, always come from a horizontal line. And it says of the boat from the buoy. Kind of interesting wording. But of the boat from the buoy, where's the depression coming from? It's coming from the boat or the buoy? The buoy. So the buoy who's standing at the top of the hill, you need to draw that horizontal line so that way you can get where the angle of depression is. Because the angle of depression is not right here. It's not. It's actually up here because it comes from the horizontal line looking down to the boat, which is the same as this angle. Exactly. It's from the horizontal to the hypotenuse, not from the hypotenuse to the vertical line. It's always horizontal. And remember what I discussed before was that you have opposite interior angles, so we're actually talking about that angle right on the inside of that right triangle. That's what we're looking for. Okay? So look at that a little bit better. This is 60, this is 100, and we're looking for this angle right here. What trig ratio am I using? Tangent equals what over what? Whenever I'm looking for an angle, I do the inverse. And I'm going to round to 3 significant figures. So 30.96, so 31.0.
Pardon the interruption. Miss Albritton, please call the front office. Miss Albritton, please call the front office.
Okay? Questions?